Today's topic is the derivative using the power rule. So last time we did the derivative by definition. That's where we had to basically do the slope formula as the distance between the two x values became 0. Today we're doing the shortcut. You might hear this is called a derivative shortcut. So the power rule. This only works if your function looks like a polynomial. This doesn't work for trig or if you have a rational function. There's all sorts of other rules. Those who take calculus again will learn a lot of those rules. We got the product rule and quotient rule. But anyway, so today's topic is the power rule. So the idea is, well, actually, let me pause here. Let me do a derivative by definition and see if you can figure out the shortcut rule on your own. So I'm going to flip over. So our topic today, though, our learning target is you should be able to find the derivative using the shortcut or the power rule by the end. You don't have to do them all by definition. So let me start off by doing an example. By definition. So I'm going to take my function. F of x is going to be equal to 4x cubed minus 5x squared plus 6x subtract 3. Now you have to do this by definition. So find, how about this? If f of x equals blah, blah, blah. You don't have to write this part down. You can just watch if you want to. If f of x equals, find f prime of x by definition. So that means I would have to do the derivative by definition is the limit as h approaches 0 of the difference quotient, which means all the x's should become x plus h. So that would be 4 times x plus h cubed minus 5 times x plus h squared plus 6 times x plus h minus 3. And then I would subtract the function minus 4x cubed plus 5x squared minus 6x plus 3 all over h. If you're feeling gutsy and you want to try to expand this on your own, you can pause or you can just watch. I don't think there's a ton of value in you doing this on your own. It's more like I just want to get to the spot where you can see my function by derivative and see if you can figure out the shortcut. So this is a Pascals. You remember that from the end of first semester. This is a 1331 Pascals, but we have a coefficient of 4, so that becomes a 4, 12, 12, 4. So we would have 4x cubes plus 12, and remember the x goes down by 1 and the h goes up by 1. Another 12, the x goes down, the h goes up. Then we have 4h cubes. This is a 1, 2, 1, but with a negative 5, so that's a negative 5, negative 10, negative 5. Negative 5x squared minus 10xh minus 5h squared, and then I would just distribute the 6 plus 6x plus 6h, and then the rest would get copied down. Can't clean it up yet. 5x squared. Oh boy, I'm running out of room. Can I make it? Plus 3 USA. All over h. So this was our first checkpoint. If we did some things correctly, what should happen here? Everything without an h should go. So I have a 4x cubed. I've got a minus 4x cubed, so they're gone. That's got an h, that's got an h, that's got an h. Minus 5x squared plus 5x squared. That's got an h, that's got an h, plus 6x minus 6x. That's got an h minus 3 plus 3. Life is good. 12x squared h plus 12x h squared plus 4h cubed minus 10xh minus 5h squared plus 6h. That's it. All over h. I can't plug in 0 for h yet, so I got to go one line down. But everything here should have an h, so I should be able to kill an h from everything. there's 1, there's 1. Ooh, there's 1, but that's going to leave me with 2, so we got to keep track of that. That's 1, that's 1, that's 1 for this 1. So I now have 12x squared plus 12xh plus 4h squared minus 10x minus 5h plus 6. So we finally plug in for h. We finally killed the h on the bottom, so now I can put a 0 everywhere there was an h, and that's going to leave me with, okay, that doesn't have an h, so that's still 12x squared. That has an h, so that's 0, that's gone. That has an h, gone. Minus 10x. H would be 0 plus 6. Okay, now the challenge for you here is to pause, look at the original function, and see how you could look at this and see if you can figure out how you could go directly from here down to there. See if you can see the pattern. How did we get a 12? Looking at this, how did we get a 12? And how did we get x squared? Looking at this, how did we get a negative 10? How did we get an x? Looking at that, how did we get a 6? And then what happened to the negative 3? All right, well, hopefully you figured it out. If not, I'm going to show you. So here's the derivative, the power rule. So if your function is a coefficient, x to a number, coefficient x to one smaller number, so like this is x to the 5th, x to the 4th, x to the 3rd, until you get down to a spot where there's just a constant with x to the what? X to the 0th. The derivative shortcut is you take this exponent, you can multiply it by the coefficient, and then you have to subtract 1 from the exponent. So let me flip this back over here. 4x cubed. Take the exponent, multiply it by the coefficient. What's 3 times 4? 12. And then subtract 1 from the exponent. That's 2. Take your exponent, multiply it by the coefficient. 2 times negative 5 is negative 10. Subtract 1 from the exponent. That's x to the 1. Now it even works here. This is x to the 1. 1 times 6 is 6. Subtract 1 from the exponent, you would have x to the 0. And it even works here. How many x's do you have? X to the none. When I take the exponent, I multiply by what's in front. That whole term gets canceled out. So that's the derivative, the power rule for derivatives. So you just keep repeating that process over and over again. So the derivative shortcut, and if you want to write this on your unit circle, it's fine with me. Multiply the coefficient by the exponent, and then subtract 1 from the exponent. Order matters here. So you can't subtract 1 from the exponent and then multiply. You'll be off by a little bit. So this is another notation for derivative. D dx is how we read this. D dx of a times x to the n, multiply n times a, and then subtract 1 from your exponent. Okay, so let's put this into practice. So like I said, this only works if your function is in this kind of polynomial form. It doesn't have to be a polynomial, but it has to be in this sort of polynomial setup where you have a number and x to the something. So what we usually do is what's called a rewrite. So I'm going to take a look at this first one. I'm going to do a rewrite right off the bat. So am I happy with this? Yes, this is a number, x to the number. Then the next one, I'm going to do, the way that this is written is kind of goofy. So if it helps you understand it better, you can separate into this. I mean, think about it, right? This is still over 1, so if you multiplied it back, it'd look the same. So this and this these mean the same thing mathematically. Minus, this would become, well, what's in front of that x squared? A 1, so this would become 1/4 x squared. And I'm okay with the 3x, and I'm okay with the minus 7. So this is what we call a rewrite. Don't get confused. The rewrite is not the derivative. These are two separate things. The rewrite is what gets our function to look like a polynomial, even though it isn't necessarily a polynomial. We'll show you on these next examples. They're not polynomials because you'll have some weird exponents. Then I do the derivative shortcut. So f prime would be equal to, okay, exponent times coefficient, that's 32. Subtract 1 from the exponent. Plus exponent times coefficient. So remember, this is going to be 3 over 1 times 2 over 5. So that becomes 6 over 5. X to the second. Subtract 1 from the exponent. Negative 1/4 times 2, that's going to be negative 2/4, which I'm going to reduce. Actually, I'll write it out the long way this time. Subtract 1 from the exponent. Exponent is what here? 1. 1 times 3 is 3. And then subtract 1 from the exponent. So that would be no x's. Remember, x to the 0 is 1, not 0. So it's not like it times by 0. This is the one that's the problem. That's x to the 0th. So when you multiply, if you want to write that in there, you can, if that helps you understand it better. So 0 times 7, that's gone, that's 0. Now what we do is what's called a cleanup. And sort of the rule of thumb is you're supposed to put things back into the order, into a similar order as which they were given. So like, for instance, this looks like that. So that's good to go. 32x cubed. This, now I wouldn't count this wrong if you left this like this, but if we're really trying to get back to the format that we had before, we should really put the x squared back on top because it's over 1. So a real nice way to write this up would be like this. I would take a point off here because you didn't reduce, but you could leave it like minus 1/2 x. I'd be okay with that, but according to the way they wrote it, it should look like that. And then the plus 3 is just plus 3. This is what we would box in. This is what we call a cleanup. So you do a rewrite, then you derive it, and then you do a cleanup. All right, so let's take a look. We're going to do the first 3 together, and then example 4 is kind of like I'm throwing it all in one big pile for you to try to figure out on your own. So example 2, I want to first do a rewrite. I got to get everything to look like coefficient x to an exponent. So let's look at this first one. My coefficient is 3. That's the number. Now, this x to the 5 is on the bottom. What does it cost? I have to write it as x to the something. What does it cost to move an x from the bottom to the numerator? Come on. You should know this. You need a negative exponent. So that's the price that I have to pay. Minus, I like to separate these. Okay, now look, here's a good one. Here's a good one. I want to talk about this before I get going. This 2 does not need to be brought to the numerator. It's the x's that have to be brought up. So the 2 is fine. That's my coefficient, 7/2. Not a great coefficient, but that's my coefficient. It's the x to the 4 that needs to be brought up. So that's x to the negative 4. Plus the next one. Actually, you try to write the rest of these. Pause it. Try to write the rest of them. Okay, let's see how you did. So it should be then 5/4 x to the negative 2 minus 2x to the negative 1 plus x minus 2/3. What's this called again? This is called your rewrite. What color? This is called a rewrite. You've taken your function and you've rewritten it in a format that you can now do the derivative shortcut or the power rule. So let's go ahead and calculate that. So notice I'm giving myself plenty of room because I'm going to have to do a cleanup in a minute. Exponent times coefficient, subtract 1. So that'd be negative 15. X to the negative 6 this time, right? That's negative 5. So if I subtract 1, that's negative 6. I'm going to clean this one up right away. Plus, so that's going to be 4 times 7, right? The negative and the negative makes a positive. 28 divided by 2 is 14. X to the negative 5. I'm going to cancel this, so that's going to be a minus. That's going to be a 2. Those are going to cancel. This becomes 5/2. X to the negative 3. Negative 1 times negative 2 is positive 2. X to the negative 2. That's x to the 1. So 1 times 1 is 1. X to the 0. If that helps you, write it out. This is x to the 0th, so that's gone. Derivative of any constant, if you don't have a variable, derivative of any constant is 0. Because there's no change. There's no, what's the slope of any constant line, right? That's constantly horizontal. That always has a slope of 0. So now we're going to do our cleanup. So our cleanup is to take everything and try to rewrite it as we did before. So you notice we didn't have any negative exponents. So we now need to bump these back to the denominators. So we would have negative 15 over x to the 6th plus 14 over x to the 5. Notice the 14 is still to the power of 1. That's not going to get bumped to the denominator. The 14 and the x are separated by a mult, which attaches the negative 5 only to the x, not to the 14. Subtract. Now this one's interesting. I already have a denominator, so I'm going to put 5 over, and I'm going to put the x cubed with the 2 in the bottom of the denominator already. That's already there. Then I'm going to bump the x to the bottom, the x squared, and then we had a plus 1 at the end. What's this called again? This part is called the cleanup. So you need to do a rewrite, then you need to derive it, then you need to clean up. So let's get into this one. Let's see if you can, I'm going to try to pause first, or encourage you to pause first. See if you can remember how to rewrite this. Let's see how you did. So we're trying to do my coefficient is 4x to the something. So as you remember, I don't know if you do remember, but to the 8th is going to be the numerator, and then the 5th root becomes 1/5. So you put the 8 and the 1/5 together and get 8/5. Minus 3x to the, what kind of root is this? It's a square root, so there's a little 2 here, even though we don't write it. There's a 1 there, so this becomes to the 1/2. Plus, coefficient is 2, x to the 3/7, but it was on the bottom, so that would be negative 3/7. So that's my rewrite. Now I'm going to start a new line with f prime. I'm going to encourage you to pause here and try to derive this on your own. Let's see how you do. Okay, so I'm going to kind of do a lot of this in my head. So this is 4 over 1. 4 over 1 times 8/5, that's 32/5. And then I got to subtract 1. Now, if you can't do this in your head, that's fine. Go over to the margin, do what we call margin work. We do this a lot in calculus. So I want to take this exponent and do what? I want to subtract 1. Actually, well, that's okay. I want to talk about this in the margin as well. So 8/5 minus 1. Well, what does this 1 have to be for me to have common denominators? I'm going to be lazy and just write it over the top. 5/5. So what's 8/5 minus 5/5? 3/5. And if you couldn't do the 32 over 5 in your head, go over to the margin. We wanted to take our coefficient, which was 4, and we wanted to multiply it by our exponent, which was 8/5. How do you multiply a number times a fraction? Well, that number's got to become a fraction. So then I multiply how? Straight across. You don't need a common denominator. So as you do these, as you do the multiplication, if you're struggling to do it in your head, go to the margin and do it. All right, so negative 3 times a half is negative 3/2. X to the, now this gets interesting. 1/2 take away 1. That's 1/2 take away 2 over 2. So that's negative 1/2. And then negative 3/7 times 2 is negative 6/7. X to the, and I need to subtract 1. Now this gets a little bit nasty, so I'm going to go over here. Negative 3/7, take away 1. But I want that 1 to be a common denominator, so I'm going to make it 7/7. So minus 3 minus 7 is minus 10/7. All right, well, there you go. There's most of your points. I think this will probably be 2.5 out of 3 possible points. So the big thing, I don't want the cleanup to be the difference between, you're doing really well but kids who can't clean up, I don't know if you just necessarily should get 100%. So now our cleanup means put it back into the way that it was written before. So as I look at this, we didn't have any fractional exponents. So I want to kind of rewrite this like this. Now, if you wanted to leave this coefficient out front, I would get it. That would be fine. I'm going to bump that to the numerator. So I'm going to have 32 times, so the 5 is the root and the 3 is the exponent. So that's the 5th root of x cubed over 5 minus, okay, I've already got a fraction top and bottom, so I can bump this to the bottom with the 2. So I've got 3 over 2 times the square root of x. Now I like to keep that multiply in there so I don't get the coefficient mixed up with what kind of root I'm trying to do. Minus 6 stays on the top, 7 times the 7th root of x to the 10th. There's our cleanup. Now this is actually a little bit sneakier of a cleanup than for my AP Calc kids. I want to show you a little note here. This fraction would actually look like this probably on a multiple choice test. 6 over 7x times the 7th root of x cubed. That would be the real cleanup there, because this is x to the 10th, which is, there's more x's underneath here than there are roots. So I've got 10 x's with 7 roots. That means I can group this as x to the 7th times x to the 3rd. So what's the 7th root of x to the 7th? That gives me 1x on the outside, and then this x cubed would still leave the other ones in there. So just for future reference, I mean, you don't have to do that. I wouldn't even consider that a point in this class, but down the line in AP, that will become an issue. Okay, I'm going to encourage you to pause here on this last one and try it all on your own. So this is kind of a mishmash of all the different moves that we've done so far. Okay, let's see how you did with your rewrite. So this would be 3x to the 7th plus 3/10 x to the 5th. Subtract 2/3. I got to bring this one up, so that's x to the -4. That's our 1/2 as my coefficient. X to the, that's the power, that's the root, so 5/4. Minus, my coefficient is 3. I'm never going to fit all this. X to the -2/3 minus 5x plus 11. Oh boy. Here's my rewrite. Now let's do the derivative shortcut. F prime of x would be equal to 21x to the 6th. 5 would cancel, so that's 3/2 x to the 4th. That would become a positive 8/3. Subtract 1 would become -5. Plus 5/8 x to the, okay, 5/4, take away 1. That would be 5/4 minus 4/4. That would be 1/4. You can't do that in your head. Margin, margin, margin. Do it down in the margins. So a negative times a negative is a positive. 3 times 2/3 is 6/3, or just 2. X to the -2/3, take away 1, would be -2/3. Take away 3/3, which would be -5/3. Minus 5x would just be -5. Plus 11. No, that would be, that's x to the 0. That's a constant. Game over. So let's try to clean this bad boy up. 21x to the 6th plus 3x to the 4th over 2 plus 8 over 3x to the 5th plus 5 times, that's a 4th root of x over 8 plus 2 over the cube root of x to the 5th minus 5. Definitely not enough room. For those of you taking AP, I'm going to encourage you to pause here and see if you can clean up this term a little bit more. So that would be 2 over, so that's x to the 5th underneath an x cubed. So I would break that up into x cubed and x squared. So 1 full x would make it out times the cube root, and there'd still be 2 more x's stuck underneath. All right, folks, that's it. Give the homework a try. This will get a lot smoother the more you do it, but this sort of switching back and forth between roots and x's on the bottom and roots with x's on the bottom is pretty complicated until you give it some try on your own. Good luck.